Control. So mostly it's vocabulary today. Control is a way of keeping other variables constant for all experimental units. Or it's an attempt to keep other variables constant for all experimental units. So we're trying to limit the effects of extraneous variables. What was the other word I used for extraneous variables the other day? Does anybody remember? Lurking, yeah, lurking. We want you to use extraneous if you remember it, but lurking will also work. Extraneous is sort of the new better term, I guess. So control is different than the control that you would use for a scientific experiment. It doesn't quite mean the same thing in stats. It's trying to limit these extraneous variables. Placebo. No, it's a placebo, not a gazebo. Come on now. Okay, a placebo is when some inert treatment or sugar pill is given to a subject. The idea, it's to give them the idea that they are getting a treatment when they are not. To give the subject maybe the belief that they are being treated when they are not. In the last class, it was like quinceañera music or something like that. I don't know what's going on over there today.
It's a movie. It's a Japanese anime.
Yeah, but what was happening, that doesn't explain. Okay, all right, so anybody in here planning on going into the medical field? Yeah. Okay, so if you're a doctor perhaps, and you have a patient that comes in with some ailment that you might believe to be psychosomatic, right, in their head, perhaps you would prescribe a placebo and tell them, here's the pill, it's going to right all of your wrongs. suggestion might actually cause the ailments to go away. So power of positive thinking with humans is or the negative thinking is quite strong. It really wouldn't work for dogs. Like if you're treating a dog, if you're a vet and you're treating a dog and you're doing an experiment with dogs and you're trying to see if a pill versus a non-pill would work, you don't really have to give the dog a non-pill, right? You don't have to give the dog a placebo.
Well, so my sister received this a few months ago. I didn't know what it was, and it was really embarrassing. But she explained it to me like in Harry Potter when like he has the good luck and he gives it to Ron, but he didn't actually.
Right.
And he like wins the Quidditch tournament.
Right. Exactly. Ron and the liquid luck. Yep. That's a great example of a placebo. Yep. That is a great example. So what do we have then? We have the placebo effect, which is what Ron experienced with that. I'm going to actually add that. Ron and liquid luck. Yeah, because why would he waste liquid luck on Ron anyway? I mean, let's be honest there, right? Come on. Ron's a redhead. He's got no soul. And come on, how did Ron ever end up with Hermione? That just never made sense to me. Hermione was dating way below her. Come on. Come on, I'm on a roll.
I stand wrong.
So you're complaining about me shading Ron when in fact I think I just shaded everybody that has red hair. But that's okay with you. But don't get specific about Ron, right? Okay.
No, not you. Shy like looks away. She's like, oh.
Okay. Subjects respond favorably to a placebo simply because they believe they are being treated. Okay. Ron and liquid luck. That's awesome. I hadn't thought of that. Okay. So then we have blind and double-blind experiments. If an experiment is blind, then that means that the subject doesn't know what treatment they are given. They don't know if it's a placebo or maybe you don't have a placebo in your treatment group, but the subject doesn't know what treatment they are given. I mean, think about it. It would be a real problem. Let's say I'm giving McKenna. I'm a a researcher and I'm giving McKenna either a drug that will give her liquid luck, or a placebo. And I tell McKenna, here McKenna, here's your placebo, good luck. Right? How effective is that going to be? It's not, right? So in terms of placebo, we pretty much have to have blind experiments. Because if you knew it was a placebo, you'd go, gee, thanks for the sugar pill. I love it. It'll boost my energy for about 10 seconds. Double blind is where neither the subject nor the researcher knows what treatment is given.
He's like, so what am I looking at?
Yeah. Somebody knows. It's just not the researcher who's actually administering the treatment. I'll explain in just a second. I probably should be more specific. The researcher giving treatment. Knows what treatment is given. So here's why this is important. It's because people are particularly good about reading people. So if I go to Sydney and I say, Sydney, you're my research assistant, I'm going to give you a drug to give to Magnus. And so Sydney then is the middle person. Now I know whether I gave Sydney the placebo or the drug, but Sydney doesn't know. So Sydney goes to Magnus and says, here you go, Magnus. This is the drug that's supposed to do whatever it does. Okay, makes you fly. All right, literally, like through the air, you got feathers. Okay, so maybe it's Red Bull. I don't know. Yeah. So Magnus goes and tries to jump off the school to test the effects. Right? No, let's not do that. But the advantage to that is this. If Sydney knows that she's giving Magnus a placebo, her interaction with Magnus could be different than if she knew that she was giving him a drug, and an actual drug that might do some good for him. And we tend to be pretty good about reading that. So it's like, let's see. Here's the drug for today. Good luck. That might be the response of somebody. Probably not that bad, but some of us are not good actors. And the person reading the researcher could sort of figure out if they've got a placebo or not. Does that make sense for why that's important? Yeah. So blind and double blind, pretty much always used with any kind of placebo involved thing. All right. Got a couple more things and then we're done for today. We'll go over a couple problems and set you loose. How about a factor? A factor is a manipulated variable that may cause a change in a response variable. So a factor could be like a drug concentration, maybe. You're getting the drug, but maybe you're getting a higher or lower dose. So, dose, perhaps. Or concentration, something like that. Next one is control group. So we have control and we have control group, and there are different ideas. This is more of like your scientific idea. Your control group provides a baseline for comparing treatments. The control group is generally the group that doesn't get the treatment at all, the placebo group. So, and lastly, replication. Have we repeated the experiment enough, or do we have enough experimental units to gather good data? So there are enough experimental units in an experiment or observational study to gather good data. So we have roughly, well, a little more than 2,000 students here at Centennial now. I don't know the exact number, it changes daily anyway, but so let's say we have 2,000 students here, and I do a random draw from all 2,000 students, and I want to know what is Centennial's favorite color. So I randomly draw 5 students out of Centennial, and I ask them what's their favorite color, and I get some response, and I find out that blue is their favorite color. Have I replicated the experiment enough for it to be reliable? No. No. Just out of curiosity, how many do you think I should question? 200? That'd be a fair number. That'd be plenty. I can tell you that. Statistically, that'd be more than enough. So that'd be 10%. Anybody think it could be less than that? Yeah, what do you think? Yeah.
Probably just 50.
50?
Yeah.
50 would also be an acceptable amount, statistically. Yeah. Yeah, 250. Assuming that your sampling method has a appropriate level of randomness, it doesn't have to be all that many, but 5 is not enough. We'll deal with how many later, but 50 is plenty. I'll let you know that. Okay? All right. Good. So let's go.